Hello, everyone. Me and Justin will be giving a brief introduction to our project, a Bayesian analysis of mortality rates across New York State. To start, I'll tell you about why we chose this project and what our objectives were. Our motivation was to assess healthcare quality across New York State. Varying mortality rates following cardiac surgery can indicate regional disparities from differences in surgeon experience or location-based resources. In our project, we explore how region and surgeon influence the success of cardiac surgeries, which we measured by surgery mortality rates. We decided to explore this mortality rate through a beta binomial hierarchical model. Our data set came from the New York State Department of Health and contained 18 variables, of which included the number of cases/surgeries, the number of in-hospital and post-30-day deaths, and both the observed and expected mortality rates for cardiac surgery by surgeon. There were a total of 6,628 observations before we cleaned the data, and because there were multiple observations per surgeon, we created a new data frame that summed the number of cases and deaths into one observation per surgeon.
Moving on to our exploratory data analysis, to the left is a table of the number of observations per region. Staten Island has the least number of observations with 8, while Manhattan has the largest number of observations with 88. And to the right is a bar chart of the observed mean mortality rates for each region. We observed that the mortality rates do vary per region at first glance, with region 7 corresponding with New Rochelle having the lowest observed mean mortality rate, while region 8 corresponding with Queens has the highest observed mortality rate by a rather large margin. And below is a table displaying the values for the mean observed mortality rates for each region. Continuing on with our methodology, we're implementing a beta binomial hierarchical model where we use the random variable Yij to represent deaths for surgeon I in region J. The sampling density for Yij follows a binomial distribution where Nij is the number of cases for surgeon I in region J, and Pij is the mortality rate for the surgeon I in region J. We assigned a beta prior for Pij with parameters alpha and beta, and since these two parameters are unknown, we specify a hyperprior distribution for both alpha and beta. What are these hyperprior distributions we assigned? Interested in our results, implications? Make sure to stop by our poster on Tuesday. Hope to see you all there.